there's a malfunction, and then a fire breaks out and kills people. And the thing that scares the shoot out of me, the lithium ion battery, the runaway takes like 4 seconds, and it's going to 7,000, 8,000 degrees.
Now, the question that I actually want to ask to the viewers and ultimately decision makers is, how big an incident with how many deaths do we require to actually get to the point to say, okay, we might have to revisit how we risk assess and what technology we require.
Being an electrician means you gotta stay current to survive. You're on the bleeding edge, dealing with brand new tech all the time. It's technology that has the power to change the world. But one wrong move, and it's an early retirement for you. So handle with care. When you're dealing with anything electricity, David Moss, CEO of Patriot Electric, can't stress enough the importance of training and safety. Doing it by the book. His 40 years of experience in the industry speaks for itself. You've heard of the saying, safety regulations are written in blood? They exist for a reason. Most of the time, somebody had to learn the hard way. This episode of Electrical X Factor is all about danger. Electric vehicles and solar panels are becoming more widespread. What this means is buildings need to accommodate these changes. They need to be able to handle the increased load. More people are charging their EVs up at home. If something goes wrong, maybe it takes someone a long time to charge up their EV, or maybe they burn their house down. They're also charging in condominium parkades or at work, in commercial properties. Most people don't know enough about what's actually inside their cars. And if the unthinkable should happen, it only takes seconds. In a parkade full of people and other electric vehicles, there could be tragic consequences. But there is a way to prevent this from happening, which we'll hear all about later on. David Moss deals with electric vehicle charging infrastructure. Right from the start, he's seen where things can go off the rails. If you don't own an EV, you might be wondering, can I plug it right into the wall?
Well, no, you can't. Some people do. It's not the code. So those are DIYs, do it yourself, or DIYs, I should say.
DIY stands for doing yourself in, just so you know.
That's where people can burn down their houses and stuff like that, right? So if they've got families and so on, you can't do that. You got to this is regulated work for an electrical contractor to do so they can save lives and make sure that you're going to be safe and your neighbors are safe so that we don't start burning houses down and potentially losing lives. So here's the deal. I saw this happening. I jumped on this bandwagon at least 5-6 years ago, EVs, at least 6 years ago, probably. And so at the time, we started to identify the issues, the concerns about, okay, well, how are we going to get an average 1950s home with a 100 amp panel? How is he going to be able to plug in an extra 40 amps worth of load and charge that overnight? Well, they can't. Either you do a service upgrade, which is going to be between $4,000 and $5,000. So not everybody can afford that on top of an EV. We started to identify, well, there's going to be some energy management concerns going forward, find out some solutions on how we can develop some energy management systems to offset these concerns with regards to not having enough power to put EVs in. And then all of a sudden they started to develop those, but they weren't certified, they weren't listed, they weren't regulated yet. And then on top of that, once they did, then we had to get the codes changed to where we could actually have those energy management systems be a viable means of protecting the consumer's service, rather than having that service being upgraded from $100 to $200 and spending $4,000 to $5,000. We developed a technology where they could spend $1,000 to $1,500 and have that protection in place. And it was now recognized by the Canadian Electrical Code as a means of managing the consumer's load. And that's where we started to see those coming on, and they've been improving ever since. So we're now getting a handful of great manufacturers that have produced these products that we can go in as electricians and say, no, save, your $4,000 or $5,000 upgrade. We can put this in place and so on and so forth. But there is limitations to that, because there's certain parameters where if you're already over your rating of your service based on the fact that you just been an irresponsible consumer and you've put a 100 amp service in your house, or you have a 100 amp service and you just added a hot tub, sauna, you've added in this and that, and all of a sudden, not having a proper electrician do a load calculation along the way, which is what they should have been doing. For added load, you have to do a load calc. And if they didn't do that, they just had it done by somebody that didn't do that. Well, now when you have time to come and get a regulated EV put in there by a reputable contractor who does a load calculation and they're already over, you're done. You have to do the code service increase now. You can't put that energy management system in. You can only put an energy management system in if you're under the code load. So these are things that you learn along the way, but I mean, not everybody knows that, right?
It's like calling the plumber after the basement's flooded. Instead of undoing the damage, it's probably best to get it right the first time. It's not really a trial and error process either. There's a proper way to do it.
When you talk about safety and dangers, the beauty of our industry is it's heavily regulated for safety. It's under electrical code. So we're really under the microscope for making sure that we're following the industry standards, policies, procedures, safety requirements. It's heavily regulated. And so therefore, we have a minimum of dangers that actually cause real harm. Now, here's the big if. If you have a certified electrical contractor doing the installations with proper permittation and so on, then you're in that system that's governed and controlled by these regulations that are put in place to save people's lives and to protect property and so on. So this applies to both solar systems, energy management systems for that matter, and or the EVs. It's a regulated work that we touch. But the danger lies when you have non-certified people doing regulated work. Now you have cowboys, for lack of better words, or DIYs or DYIs, getting involved in doing electrical regulated work or playing with these things that they can just go ahead and add together. And these can be all the way from residential installations to, say, industrial installations. They can get severe. Specifically, if we talk a little bit about, say, solar, well, there's multiple different solar types. There's the AP, which has a built-in microinverters. And then there's the string inverters, which are DC power. Now, the big deal here is DC is non-forgiving. You cut into a DC line and you're going to be hooked, typically, because it's got no AC wave. Because an AC wave allows you to go to 90 degrees, back down through zero, down below 90 degrees, and back to zero. So every time it goes through zero, it opens the circuit. I think it's 60 cycles a second. Anyway, DC's not like that. So I would say the biggest danger would be in dealing with DC systems because they can go all the way up to 1,000 volts. And so AP regulated microinverters, they're generally maybe 240 volts is what we're dealing with there. But when you deal with the DCs and these string inverters, you're going to go all the way up to 1,000. So if you don't know what you're doing there, even if you're a certified electrical contractor and a certified solar specialist, there's some serious caution to be considered when you're dealing with a person that's going to try and do it themselves in a remote area or in a off-grid situation where maybe it's not a regulated person doing the work. It's just maybe somebody that thinks they know. You could be looking at some serious danger there because it's high voltage that could kill you.
The problem is, electricity is invisible. It's why people underestimate gas and other chemicals too. All it takes is one touch.
Yeah, that's life and death. So that's why I say, if everybody's doing the work under a regulated permit and a regulated certified contractor, that's why you don't hear of a lot of different problems because we're so regulated and safety is such a big thing. And if you don't follow those procedures and policies and mandates of having certain certifications for your staff and so on, then you're going to run into problems.
With more people wanting to get into solar energy, there's a lot they can do on their own. But it comes with its own set of problems and dangers. Sure, it just sits there and absorbs energy from the sun, but installation can be tricky.
The voltage is a concern in the solar world. Who's doing the work? It's got to be a regulated contractor. The other thing that, if you talk about tech and solar, typically solar is either on a roof, and sometimes those roofs can be pretty ambiguous because there's 12 pitches, really high pitches, low pitches. So anybody that's not comfortable with doing roof work is generally not going to be your solar person. That's another concern about that tech is you're having people working on a roof. Not everybody's cut out to do roof work. So as far as danger, yeah, you could fall off a roof, you could slip, you could, you're carrying heavy panels up there. So there's some concerns and dangers involved with carrying heavy duty panels up onto the roof and then mounting them onto a very steep roof. So there's going to be fall protection required, certification for working in heights. So all of these things need to be taken into consideration. And again, for those who don't follow those safety protocols, they're putting themselves at risk. And there's the danger. I think you're going to have less danger if you got fully qualified, certified, bona fide contractors with proper certification on their staff safety protocols versus someone that's just going to try and figure it out on their own. I mean, they can do it, but it's going to be dangerous for sure.
There are a lot of great resources to learn from to get a better understanding of the systems, but it makes the whole process seem too easy. It oversimplifies a lot of the practical knowledge you need, experience that only comes with doing it. But there might not be a next time if you make a mistake.
As we all know, there's no shortage of information anymore. So anybody can go on to YouTube and see how to do something, unless it's being broadcast and published by a legitimate contractor or school or industry. It could be just somebody's backyard ideas. So here's where that comes into play in regards to service calls coming back to us and so on and so forth. When we get a call out to do a new installation or a repair or a modification to a system, we are now what the electrical code classifies us as. If we go into a site and we see something that's unsafe, that's not to code, non-compliant, it's our duty as electrical contractors and an FSR, field safety representatives, is we need to either repair it or report it. Unfortunately, that's the way it's mandated in the electrical code. So we're not trying to do anything more than to protect property and people. So when we go into a site and there's a solar system already there and we're going, well, this solar system doesn't work and we want to get it working again, and we're going to go, well, there's some real issues here with your system and that's why it's not working, and it's going to cost a lot of money. Either we're going to tear it off or we're going to put a new one on or we're going to make necessary repairs, and those necessary repairs are going to be to code and they're going to cost money. So if clients say, well, no, I don't want to do that, I want to do this, and it's not to code, well, that's entirely up to them. But either I'm going to make the repair to make it safe for them and the property. Unfortunately, if they don't want to accept that repair, that's fine. We just let the inspections know that, hey, no problem. We were on a site. We noticed some things that were not compliant. We've notified the client. And at this moment in time, they've chosen not to move ahead with that. So now what happens is the electrical inspector's duties is to contact the owner to let them know either we disconnect that system altogether, like the homeowner would be instructed to disconnect the system, or whatever unsafe condition is, the inspectors will require them to either repair it or disconnect it so that there's no risk or loss going to happen to their property. That's the way that the world works. So when we go onto sites, like you said, for service calls, a lot of times we completely back away and we just contact the inspector saying, yeah, no, we're not going near this project. There's just no way. We find this is happening. I can't really pigeonhole any particular case, but a lot of times in the remote communities, people don't always have access to certified electrical contractors all the time. So they kind of figure it out on their own, and it works. But as soon as they need a new installation for either an EV, a solar system, whatever new tech they're going to have installed by a certified contractor, and we walk in and we see that, we have a duty to either report or repair it. If you're a contractor and you don't do that, then you're putting yourself at risk and you're risking your license.
That and, well, you. You're risking your own life. You don't want to put yourself in a situation that could seriously hurt you or whoever else is next in line.
That's the dangers right now, really. I mean, that's specifically about solar for the most part. Energy management systems, again, it boils down to if a certified electrical contractor is involved, then he's probably going to install it as per the manufacturer's intentions and do it to code. So there's not a big risk on that. It's even good to know that if we don't have energy management systems going in, though, that's where the danger lies, because now people start to add things into their systems, into their electrical service, that is putting it over capacity. And so in a situation where they have all of that load added on at once, they're going to put serious strain on their system, and it could cause a fire. So the energy management systems are a stopgap into protecting the overloads and exceeding the capacity of that service's ability. That's where the danger can lie. It's because of people adding too many things like extra saunas, extra hot tubs, pools, EVs, like you name it, all the new tech they're adding, because maybe their home was built back in the 50s and 60s and it doesn't have enough capacity to add these extra loads. So now they're going to overload. And that's where things just aren't designed. They're just not meant to take that extra load, and something's going to give. And there's a myriad of different outcomes there, and most of them aren't pretty.
Let's get into it. If owning an electric vehicle is in the cards for most households and families, there has to be some way to keep it charged up. What do people really need to be aware of?
You can plug it into an external outlet in your house. It's going to take forever to charge your car. That's the drawback. So the lower voltage, the lower amperage versus the higher voltage, higher amperage is a direct relationship to how many kilometers you get per hour charge. So when you plug it into the outside of your house, it's going to take you a long time. If you don't have kilometers to travel, then that might work for you. But in most cases, if you're traveling any distance, you're not going to get the job done unless it's going to be on for days. So anyway, there's lots of facts and figures to go through in regards to how far you're traveling each day based on how long it's going to take to charge that. The worst thing is when you start putting in adapters and trying to like extend things. If you're starting to mess around with cables and you're doing adapters and trying to add one length onto another length, and it's using some kind of an adapter on that, and you're exceeding the length, that's where everything starts to fall apart, because there's all kinds of technical things like line loss and voltage drop. Now you're exceeding the capacity and the ampacity of these cables and so on, and the usage of these cables. So it's a problem. Now, when you get into the EV world, though, again, like we talked about, there's a huge load there if you're going to maximize that ability. And that's up to 40 amps, 240 volt, just like your range. Just like your range in your home if you have electric range. Any electrical contractor knows that. When they do their permit applications, it's required to do a load calculation. If you exceed the load calculation by adding that extra EV load, then you have to either put a management system in and deal with it that way. But nonetheless, EVs, again, will cause a huge amount of load. And the danger there is if people don't take the proper precautionary measures to limit the load, then they could overload their systems. EVs in a commercial application, same rules apply. It becomes a little bit more complicated when you're in a multifamily dwelling. If you're doing it properly, everything is engineered that way to work seamlessly within that electrical building's characteristics. That's why it's less likely to see a problem and a danger in a commercial, because generally they're run by either property owners that take responsibility for contacting anybody that's going to put these in. They're not just going to bubblegum those in. Maybe a single family home out in the middle of nowhere might, or even in town if they're going to try and do it. But generally, commercial properties, there's less likeliness of someone being irresponsible on adding those EV loads, considering there's a lot of permutation and liability that these stratas and these owners have to take, because they're putting a lot of people at risk if they do that. And I don't think they're willing to take that chance, in my opinion. EV loads are a huge responsibility. And then we're also talking about when we're dealing with EVs near buildings and or in parkades. And it's not just EV, it's not just cars, it's actually EV bikes. It's anything to do with an EV, for that matter. It's such a thing. It's such a thing right now. You can look around the world right now, and there's news articles everywhere about problems with EVs.
Electric vehicles to catch fire. They burn hotter and longer thanks to the lithium-ion battery. Some firefighters need more training to fight EV fires.
You don't have to look very hard to find these issues. They're not too different from other top-of-the-line electronics. Concerns about battery range and eventual degradation, replacement costs, even cheap-feeling materials and manufacturing defects. And we're not even getting into the debate about self-driving cars.
EV bikes, anything EV, mobility devices and or cars, they're all in the same boat, unfortunately. And so there's some real risks there. It all becomes very, very easy to see where consumers get caught up in the ability to think they're doing something for the carbon footprint. They look at buying these new EVs. They're motivated because they think they're doing a good job and they're saving the world. And that's fine. And that's up to them. But no education is being passed on to the risks and the responsibilities of those people that buy these. Because the risks and the responsibilities have everything to do with their ability to tap into a infrastructure that's going to be suitable for that EV mobility product. Is it rated? Is it safe to where it is? What's the chances if something's going to be damaged? There's just a multitude and an array of risks and responsibilities those consumers aren't being educated on by either the retailer or by the manufacturer's representatives, dealerships. And I think that there should be some more work involved in either working with electrical contractors to support their sales. In the early years of EVs, in the early years of like 6, 7 years ago, when we started dealing with Tesla, Porsche, and Mercedes, and we started working with these manufacturers and these dealerships, we went in and we started to become certified installers for their EV products. But that dropped right off the floor. The sales team did not follow through. Once they delivered that car, they were like, bye, when's the next sale coming? So they didn't really care about the consumer as much as you'd think they should have, because once they're out the door, it's on them. And nobody was taking any responsibility. As a matter of fact, it was so crazy. I've heard so many stories. There's people buying EVs, plugging into their dryer outlet. You know, like that might work right now, but there's no safety built into that. There's no GFI protection if they're dragging that corn outside.
GFI stands for Ground Fault Circuit Interrupter. It's a handy device in electrical systems, or built right into power cords, that helps protect you from getting zapped. Seriously, electrocutions are way down, according to the U.S. Consumer Product Safety Commission.
When you're outside, you need to have proper GFI protection. And most of your chargers today have integral GFI protection. So if you're outside, you know, you're not going to get electrocuted if you touch something that's got a short on it. Well, it's going to minimize that chance. But if you're just plugging it into a dryer, they ain't no GFI. So if you're dragging that cord outside, you're plugging it in, it's raining, yeah, you're in a world of hurt if you got a problem. So there's some room for improvement on the manufacturers' representatives. Who's ever selling these EV mobility products, they should be educating their clients on what the proper solutions are for plugging into an infrastructure so that they're safe and their property is safe. Because around the world, places are burning down, people are dying. I'm not trying to paint a horror show, but I mean, I think that I just don't see a lot of education out there being done.
And then there's the issue of explosions. EV batteries themselves don't explode, but they catch fire. And it's the gases in a chain reaction called thermal runaway that do explode, even while the vehicle is parked. It doesn't happen often, and analysts have said that gasoline vehicles are nearly 30 times more likely to catch fire than EVs. But if it occurs, it's not a regular fire. If that sounds scary, that's because it is scary.
But sprinkler protection on its own is not enough to actually stop and control the spread of these battery electric fires just due to the intensity of them. You need in excess of 20,000 liters of water to extinguish a battery electric vehicle.
That's Herbert Schmitz, Global Segment Lead in Mining for Luna Innovations. He's here to walk us through the worst case scenario when it comes to an electric vehicle catching fire, how it happens, the consequences, and perhaps most importantly, a promising solution.
This is quite an interesting, call it, topic for someone that has a background in mining automation. So I started my career in mining and I have developed some really unique safety systems within mining. I think that created a basis for a unique skill to solve problems.
It's a lot of pressure. Herbert Schmitz's job was to figure out everything that could go wrong, from every angle, accounting for every possible event. Because if he didn't, it could mean losing lives. He's a problem solver.
I always say, if we can prevent failures, we can surely prevent fires. And that's ultimately the philosophy to this conversation as well. How can we mitigate the risk of battery electric vehicles within our everyday lives, within our open as well as enclosed multi-level parking infrastructure? Now, the media isn't kind to these fires. And on LinkedIn and on the news, there's quite the frequency of electric vehicles being on fire and the risks involved to not only the firefighters fighting these fires, but to average Joe that owns and operates these vehicles and people within the vicinity of these vehicles, within the parking garages and shopping malls that we daily live in and do our business by.
Cars these days are made up of approximately 50% plastic. From 2012 to 2021, the amount of plastic increased by 16% on average, according to the American Chemistry Council.
And that ultimately relates to them burning about 5 times hotter and significantly longer than they did in the 70s, and even more so for battery electric vehicles. Combined with us sticking them in more confined spaces and really trying to optimize the usage of space within parking environments, we create a really high cocktail and energy density for a fire to spread from one vehicle to another. But there's another risk that we need to have a look at, and that's the release of toxic and flammable gases that would influence your ability to evacuate if in a process of thermal runaway of a battery electric vehicle. Now, they release a significant amount of hydrogen fluoride, which is a very toxic gas that can be absorbed through your skin. Now, that creates a very unique risk, as I said, to anyone that's in the vicinity in that parkade that needs to escape that environment, but also the firefighter that needs to fight this new risk, this new problem. And this is something that is to a much lesser extent with internal combustion vehicles. Now, if we build this out even further and we have a look at the BC Fire Code, British Columbia Fire Code, and we do a literature review on the Canadian Fire Code and the NFPA standards, to some extent in British Columbia Fire Code, actually has a requirement that if the risk changes, then the fire suppression measures to address that risk should also change. But the reality is, in practice, that does not happen. The parking garages is still designed for vehicles in the 70s out of a fire protection perspective.
With the amount of people who have already adopted electric cars, it's outpacing appropriate safety regulations. It takes a titanic event to spark change.
And to put this in perspective is that we only require fire sprinklers in enclosed parking garages, and we do not require any fire protection in open parking garages. Now, with the latest NFPA 13 code, there was a move to say that we move from an occupational hazard 1 to an occupational hazard 2 for all parking environments due to the risk of electrical vehicles. So that only states that we should have now sprinkler protection in. But sprinkler protection on its own is not enough to actually stop and control the spread of these battery electric fires just due to the intensity of them. You need in excess of 20,000 liters of water to extinguish a battery electric vehicle. Added to that, the accessibility and the confined nature of that environment, it makes a really difficult environment for firefighters to address that specific risk and get enough water there. And we're not even talking about what sprinkler systems can give. And that's minute water quantities against what is required. So an internal combustion vehicle has a lot less inherent energy that burns. So in most cases, if you could separate that vehicle from other vehicles, it would relatively quickly lose energy and burn out completely by itself. So the total heat release rate is a lot lower. But that said, you would only require about 3,000 to 5,000 liters of water in a case of a small internal combustion vehicle compared to 20,000 liters of water in a battery electric vehicle, for argument's sake. So that in itself is unique risk. Furthermore, you only have about less than 10 minutes before a fire from a battery electric vehicle spreads to adjacent vehicles. And if it's adjacent to another battery electric vehicle, you have a much higher risk because that thermal energy already accelerates the thermal runaway in the next battery cell in the next vehicle and so forth. And that time frame becomes shorter. Statistically, if you could stop the spread of a fire to about 3 vehicles, you potentially prevent the collapse and a rapid spread of fire within a parking environment. But the moment you go past 3 vehicles, the fire spreads very quickly and the potential for structural collapse is very real.
It's not just flames and smoke firefighters and people need to be worried about when a battery fire like this breaks out. It has the power to level buildings.
So if we look at the time frame, we have less than 10 minutes to actually react. And that is less time than a typical fire service could potentially get to this vehicle currently. And keep in mind that the current fire protection measure is not based on early fire detection or thermal monitoring. It's based on fire sprinkler heads, and that's very late stage. We already have a fire for a moment before that activates and that triggers a fire alarm, and potentially that triggers the response of the fire department. Now, this is where the real need comes in. There's some interesting things to note out of the BC Fire Code in addition. Because battery electric vehicles release flammable and toxic gases, the BC Fire Code actually states that if you have electrical infrastructure that has the potential to ignite an explosive atmosphere, this equipment, there should obviously be an increase in the fire detection capability and fire protection measures within that installation. Now, that's true for industrial facilities and manufacturing facilities, but the reality is that battery electric vehicles do release these flammable and toxic gases. And in most cases, there is the requirement to have charging stations and other equipment in that environment. So by risk assessment, we should improve our detection capability.
There are a lot of these batteries already all over the place. And there's going to be more.
And they all pose a unique risk that we've not designed into the environments that they operate in.
If more people knew about this, they'd be freaking out. It's chilling. Of course, electric vehicles obviously aren't blowing up left and right. Otherwise, nobody would be driving them today. It's a unique risk, but one that is becoming more and more likely to happen, especially if things continue the way they're going. David Moss says no two EV manufacturers are the same, and that's what's got him worried.
The EV business is booming. There's no doubt about it. I mean, there is some declines in some of the purchases because there's some buyer beware. Not all the information that's available on EVs is being advertised and put out there, except if you go doing some research on YouTube or wherever you want to go to get your information. There's a lot of manufacturers, they're having to build so fast for so many that their costs for doing so to get their manufacturing up, it costs a lot of money to do that. So they have to cut costs, so they build inferior products, and it's at the expense of lives. The amount of mandated electric bikes that are having to be made in certain parts of the world. So they're mandating these new bikes. These new bikes are all being made somewhere, and they're being made with such speed and inaccuracies. The products are having to be compromised to being a lesser value than what they used to for the more expensive type of bike. And you've got people buying these, and then it becomes an issue where do we store these? Where do we charge these bikes? Where's the proper circuit to plug them into? Well, I don't have anywhere in my home. I can't park it in my home. So I'm going to park it in the hallway. I'm going to park it in the elevator, whatever. And all of a sudden there's a malfunction, and then a fire breaks out and kills people. And the thing that scares the shoot out of me is that the lithium ion battery, the runaway takes like 4 seconds, and it's going to 7,000, 8,000 degrees. You're going to get what you pay for, bottom line, right? But not everybody can afford those nicer vehicles. So some people may be forced into it.
But there are solutions to these problems. Herbert Schmitz's experience in mining and fire prevention uniquely positions him to apply lessons he's learned in an industrial setting. That means he's had all kinds of data to sift through and come up with what he thinks is the best way to prevent these fires from happening, or at least give firefighters a head start. It's called linear heat detection.
Mining, as we all know, is potentially the most dynamic and hazardous type of environments we can work in. And if you work and develop solutions for that environment, it really opens your eyes to the application of technology and processes in saving lives and mitigating risk. That led to a long career in a fire engineering perspective, where designed life safety systems for more than just mining applications, but into commercial and in heavy industrial special risk applications. And then on that journey is where I've learned about linear heat detection and distributed fiber optic sensing as a technology, developed some really unique solutions within heavy industrial applications for taking what the industry would have typically done, fire detection and firefighting on an asset, to condition monitoring an asset to a point of fire prevention. Now, a unique technology to address how early can we potentially sense a hot battery pack, because that's one thing we can potentially do even in both enclosed and open parking environments. And the solution would ultimately be a fiber optic cable as a sensor. And how this technology works, everyone knows fiber optics for communication infrastructure. We send a light pulse through, and that relates to data transfer. But we actually monitor how the light passes through a fiber optic cable. And as the light travels through that fiber optic cable, it actually creates its own minute backscatter. So a very basic example of how this works is if you would relate the fiber optic core inside to a little bottle of water, if I would heat the water, the molecules become more active until the water boils. If I cool the water, the molecules become less active until it's frozen. Now, a simple little test to do at home is take a flashlight, a little bottle of water, and keep it really still, and the light just passes through. Shake it around, and you see the little bottle of water glows. Now, it's the light bouncing against these active molecules, creating reflection within the water. Now, the same happens within the silica blast. As this laser now bounces against these molecules jumping around, it creates reflection, or we call it backscatter. The intensity of the light integrated is our temperature measurement, and the frequency of the light is the distance in the fiber optic cable. Think about it like a radar. So we then tune into those radio stations at their different frequencies, like tuning in through an FM radio, and we see what is the temperature at every single point along that fiber optic cable with extremely high distance and temperature resolution, down to 0.01 degrees Celsius, a 25 centimeter resolution. So think about it, every 25 centimeters of that fiber optic cable is a thermocouple or a temperature measurement point. And we do this for kilometers. So we could run that sensor, that fiber optic cable, for kilometers through, think about the floor of a parking garage. And we would zigzag this throughout the entire parking environment, through all the parking slots. And if that battery starts releasing thermal energy, because we don't see the off gases because it's internal into the battery before it starts venting. But the one thing those batteries do release is thermal energy. So we can pinpoint exactly at which parking bay we have more thermal energy than there should be. And that gives us that early warning and saves us those precious minutes, so that we have at least the center or the operations team and the on-site fire team to at least react, respond, identify, potentially move that vehicle, or at least evacuate other vehicles in the vicinity of that vehicle, buying precious time. And also, before we not yet have a fire, and we can get the fire department there very early on, they could actually get a lot closer to the risk. And in some cases, they actually flip the vehicle to get to the cell and start cooling the cell and containing all the thermal energy at that point.
To be clear, linear heat detection is just the warning system. It would be like a more precise smoke detector. But hypothetically, it could be a big help if responders are quick enough. They can act before it gets to the point of combustion.
See, once that battery starts in its cycle of running away, it's going to happen to itself. It has all the ingredients within it. The cathode, anode, electrolyte, and the separator plates are all fuel to the fire. They add oxygen, they add thermal energy, they are combustible. So it doesn't require any external oxygen. It creates its own oxygen within that process. That will run away and ultimately create these flammable and toxic gases that will vent, that there will be a spark that will ignite these gases, and we'll have these jets of flames out of that battery. Before all of that theatrics, the cell must release thermal energy, part of the thermal runaway process. Now it's measuring that radiant heat energy long before any other technology would have the ability to sense that. Because if our fiber optic cable is embedded into the floor, we will sense that thermal energy being radiated, and that will ultimately give us a very early alarm, again, buying us precious minutes to deal with this risk.
That's pretty impressive sensing ability to determine what's going on in that kilometer of wire. And if you run a kilometer of wire through a building, that's all the way through the electrical systems, like through the main distribution, through your transformer, through your distribution panels, through your house panels, through your meter centers, through every bit of electrical infrastructure, then go right to the roof to your mechanical infrastructure, through your air handlers, through your heat pumps, and then down back through to your fire, tied into your fire alarm system. And this now becomes a management system and a monitored system throughout your whole building. You're not just monitoring your fire alarm anymore. You're not just monitoring your security anymore. You're monitoring your whole building's conditions. And so this can tie into building management systems that are already in place that have, say, old technology, like, say, detectors and or sensors that are just unique, but these are inherently going to fail over time. These current tech is going to have these sensors fail over time based on environment, based on usage, based on damage, based on a bunch of environmental issues that manufacturers just can't produce a bulletproof product that's affordable and it will get into the market. So they're inherently going to have constant maintenance, constant repairs, constant service, and then failed systems and trouble and so on and so forth. Where if you compare that to the new tech that we're talking about, the LHD, that cable is almost bulletproof. With 25 years, like it's rated for mining. Like it's heavy duty. Like there's no like you can put this in like the extreme environments this can go into is absolutely incredible. Like super high temperature, corrosive, high, like there's so many environments that most detectors, they're going to fail every 2, 3, 4, 5, 6 months. They've got to go back in, get a new tech in there, shut down the system, get it into a controlled environment, replace that detector. Whereas this can just live in that environment and not even be a problem.
Using the cable like this gives it all kinds of utility. It's not just for one specific use case. It sounds pretty incredible, if it's as good as advertised.
The technology has a proven track record, and it's used within various other applications successfully within the industry. It's been used for fire detection in tunnels. It's been used for temperature monitoring within industrial assets and power cables. And nearly every single subsea power cable and communication cable is monitored by our technology for thermal hotspots along that infrastructure. So I've applied this within mining, within conveyor infrastructure for very similar philosophies. If something is hotter than it should be, investigate. If it gets hotter, isolate it. And that works really well. It's now the adoption of the industry within the building codes and within this environment, and to some extent, the municipalities involved, to say we need to protect our people in those environments against these risks.
In the mining industry, Herbert Schmitz has already gone through the process of getting it put into law. So the idea isn't alien technology. You can point to where officials have seen the need for linear heat detection.
I've been successful to actually get this technology written into the Mine Health and Safety Act, where it states that for conveyor belt installations, you must have this technology installed for fire prevention. So I've been down that journeys on getting this type of technology adopted within regulatory requirements within governments. It's now very early stages within, let's say, the Canadian market, and this is why this conversation is so important, that we kind of get the message out and get the public to support the thinking and saying the technology exists to do more and make the environments that we live in safer, but we need to drive government to adopt this and enforce this.
What's it going to take to actually implement this in commercial and residential buildings now?
I just want to, just emphasize how much sense and articulation that Herbert's been able to present that makes sense. And as an industry installer, understanding this for over 40 years in the electrical world and detection and the lack thereof, Herbert's presented a case that's ripe for the presentation for those people that need to hear and understand that this is what we can do. Those precious minutes could mean catastrophic differences in terms of infrastructure.
We just have to look at recent significant fires, the ones in Norway, the ones in London, the ones recently in Korea. They led to hundreds of millions of dollars in damages. In some of these cases, there were fatalities involved as well, and we cannot put a price tag on human life. And it actually boils down to the interpretation of the existing codes and standards that's already there. If we apply the rules within the codes that was potentially written for other applications, but due to the risk that is changing within our environment, and we apply the rule, it states that we need to upgrade the detection and protection capabilities within that environment and do more than just a 100-year-old sprinkler system. There is technology today that has the ability to sense thermal energy very early on with pinpoint accuracy, giving us those seconds where traditional technology is extremely reactive, and we've already lost that moment where we can react preventatively, or to some extent that we can control the scenario if we use or stick with the current, call it state of art of technology deployed or systems.
Every time we have a problem in our industry, there's always going to be someone that's going to look at that problem and make it into an opportunity. And not only for gain themselves, but for like myself, I'm looking for the ability to, if I identify a new tech, like we talk about with LHD, linear heat detection, these are going to be solutions that are coming forward now that are going to be identifying and giving the opportunity for a consumer, a building owner, to have this information by causing an alarm in a situation where they see an accelerated temperature change and so on. The LHD is not a new product. It's been around for over a decade, possibly even over almost 2 decades probably. And it's just not in Canada yet. And if it is in Canada, it's used very simply. Again, not only can we see linear heat detection in these fiber optic cables working in these heavy duty industrial mines and or large utility situations, we can now see it scaling back down to where we can utilize this detection that's not available right now in any sense of the imagination in a commercial business application and a multifamily application. It's a multifaceted product. This technology is now utilizing a single device, single cable. We can sense movement. We can sense temperature change. It's got so many multifaceted uses that I can see a great advantage to a building owner on having one cable run through their building and having so much of it take care of so many different systems that it's basically a massive information center. It's going to save them time and energy and money down the road based on the effectiveness of when to do a repair, when there's going to be an emergency event. And it's going to allow them to predict and to facilitate any kind of a measure to correct an upcoming event if they can sense that there's extra heat building up on a bearing or if there's extra heat building up on an electrical panel. So they can really zero in on where exactly that issue is ahead of the problem. The beauty is that they can now execute an installer, repair tech, boom, he heads right out to that job, right to that one location and fixes the issue without having to go around and start walking around the building trying to find where this might be a problem, what's caused it, what's going on, and all that extra time and energy spent on doing that can be really narrowed down by having the fiber do its work through its controller. So it's got so many different applications.
David Moss and Herbert Schmitz want to move ahead with linear heat detection, to bring it to the attention of the people who need to know about it and who have the power to implement it. But the path forward is not going to be an easy one. There are a number of obstacles already in their way.
Human nature is the biggest roadblock. It's the inability to accept change. The people that we typically deal with that hold office have been there for decades, and they're not motivated to investigate a new technology platform and to spend the effort to create a committee to drive the change. The reality, what drove the change, for argument's sake, in South Africa was there were 3 major fires in a mining environment. And within those 3 major fires, there was a significant amount of fatalities in each of those fires. And that pushed government to say, we have to change now. We have to adopt this technology to make the mining industry safer. Now, the question that I actually want to ask to the viewers and ultimately decision makers is to say, how big an incident with how many deaths do we require to actually get to the point to say, okay, we might have to revisit how we risk assess and what technology we require for protecting, in this case, let's say electrical vehicles within parking storage environments. That's the question. We required a massive fire in the UK in a building to change the way that they look at insulation materials. And I mean, that's always the reality, is that big incidences drive change. The question really is, if the evidence is already there and there's already been a significant amount of incidences internationally, and to some extent there's more and more publications released saying we need to change, we need to understand the risks better, we need to improve on our fire detection, fire protection capabilities, and within that we need to now drive this change. And so, I think that's really what I want to get for this.
The current codes and the current fire protection agencies have limited amount of resource solutions to mitigate this new technology coming on board. So this is where I find that the legislation and the policymakers are not reacting fast enough to industry problems and issues. We need to get on the hill and start stomping our feet and really letting people know through different government bodies and different agencies that have a voice to go back to industry leaders and to policymakers and say, hey, these are serious concerns, and this is what we find we need to make aware to manufacturers and to consumers so that they can take the necessary actions responsible to protect property and lives. I think that's happening, but it's a snail's pace, way slower than technology is moving right now. So it's going to be an interesting one, but I think we have some hope on the horizon, there's no doubt. Today, the decision makers, the policymakers, they're busy and they're dealing with all kinds of different things. It seems to be a lack of decision makers now, and nobody wants to take any risk. That's the world we live in today. And unfortunately, as an entrepreneur, as a business owner, that's my life. I take risk, and it's for potentially a reward. But that's the way we live. However, in today's world, I guess to say the corporate, the government, the municipalities, they unfortunately have a little bit of a limited acceptance to risk, and they want to deflect that back to somebody else. And that's no criticism to any one particular individual, but it's just the way that world they live in and work in is designed. It's very rare now to take someone and find them that they take full responsibility and accountability for what they're doing and providing to us as contractors. We find that there's a real challenge on having decision makers and people that will actually say, okay, the buck stops with me, I'll make a decision and I'll stand behind it. It's usually, okay, well, we're going to deflect that off to the architect, we're going to deflect that off to the electrical engineer, we're going to deflect that off to the business owner, we're going to deflect that off to the general contractor, we're going to deflect that off to the municipality, and so on and so on and so forth.
Let's put it simply. What steps are you and Herbert Schmitz looking to take immediately? Who are you getting in contact with? Who would hear you out and hopefully start to get the ball rolling?
But the problem is that the regulatory environment literally differs from municipality to municipality, province to province, country to country. And we should actually start a municipality that is worth looking at this. Let's say if it's Vancouver or Victoria, and say, and get the fire chief involved for how can you be the spear point in leading change and driving change and say, within my area of influence, would be my requirement. It would also be important to drive this conversation with the leading insurance companies and risk assessors, because they ultimately fund the bill for these incidences. They have a financial motivation to ensure the safety of these structures, or the survivability of, at least the survivability of these structures. And the moment there's adoption within a municipal environment and an insurance requirement, that leads the change within the regulatory environment.
Herbert just reemphasized and clarified the process in the direction of how we can actually see what this message is going to do. And hopefully it's going to reach a municipality that would take and become that spearhead to have these decisions made for change and be those leaders in their environment, in their influence. And then that would hopefully, again, reach back and fall on ears that are in the insurance industry, because they are a stakeholder in those repairs and having to answer for those potential damages. But again, Herbert clarified that the evidence is already there. We need to have this fall on the ears. They're going to have people want to make that change. Our biggest challenge is going to be human nature. Resisting change, not taking responsibility. Why do we need to wait for someone else or some other building to become hazardous to the point where we're going to have a fatality? This needs to be adopted sooner than later. And hopefully we can put that message out there. Herbert's environment and influence in talking to people with this is way more broad than mine. So I would say in my little bubble in Victoria here, in speaking with engineers, they immediately adopt the ideology that this is a solution, but then they're limited in their influence. Their comeback to me, I've mentioned this to Herbert before, is that in the 2 or 3 engineering firms that I've talked to instantly agree that there's room for change. This is a viable solution. Their comeback to that would be, it's not code right now. The second thing would be that there's cost incurred. And so in the constant increase in red tape, product costs, in installation costs, in just doing general construction, that most developers and stakeholders are concerned about additional costs that aren't code required. So again, those are challenges that I've seen come back.
So what I'm driving at the moment is awareness within the code compliancy environment to some extent, and with insurance companies at the moment. My energy is very much focused on Dave and his activities out of a practical perspective, where we are supporting and saying that let's get a building. Now, even if it's a small scale, get a system in, because this technology is new to a lot of people. Not that the technology has been mature for more than 20 years in the market, but it would be something new to potentially to a fire chief, and get something tangible for them to appreciate the application of this technology within that environment. So that will start driving the adoption. But within, let's say, next year, the ideas would be to present a paper on the solution at more forums internationally within the NFPA realm of thinking and within the insurance realm of thinking, and drive that. Access for me within, let's say, regulatory environments within Canada is a bit restrictive. I'm not in that environment, but that's something that we need to look and develop.
In terms of the different bodies that we can communicate to, one that comes to mind that's in my world is the Electrical Contractors Association of BC. I'm a new member of that organization, but I do know they have a political voice that's heard on the stage in BC. I think that this would be the next step for me personally to communicate with and to pass on to them. Again, they're electrical contractors by trade. They understand this risk and what these solutions might be. I think that would be my next point of contact, to have them bring this technology and solution to the table on these political, municipal, and regulatory forums. My message to the regulators would be that let's get on board with the stakeholders and the installers, not just the government regulators, but let's bring in the municipal regulators, let's bring in the institutions, let's bring in the stakeholders. The stakeholders in general all around should be brought to a discussion and start to make decisions quicker than they are being done right now. I think we need to have a sense of urgency on that. Somebody like myself, who's been in the industry over for 4 decades, a lot of them are already starting to retire. I could retire. but I'm not going to retire. I have a responsibility and a conscience, so I want to bring what I need to bring to the consumers and to the communities. I know there's lots of them out there that are already retired that have got way more smarts than I do, but they're retired. They're not interested in getting back into this kind of a time-consuming hamster cage environment that we're living in. So I think we need to get all the stakeholders together, have a discussion. I don't know how that's going to happen. I'm not that smart of a guy, but I would definitely be willing to involve in that. I am involved in that in certain ways, like I mentioned, through the community colleges and the universities. We participate and welcome a lot of the post-secondary schools, and we bring in private instruction through those industry recognized trainers to gain that knowledge and that safety procedures. So, but we talk to them and we express our concerns too, and so it's a good collaboration between them, and then they have another voice themselves when they go back and talk to, say, a higher regulator or a higher policymaker based on what they're hearing in the industry. So those are the stakeholders that I think we need to get together on. I think that's going to be the ultimate. But again, a lot of times I see Stonewalls as different professional agencies. They don't see having that input from, say, different stakeholders as valuable as staying within their own world. I find that's a little bit disturbing because I know a lot of contractors that are super freaking smart people compared to some of the other professionals I've run into lately. We put all this faith and trust, and we should, in our engineers, but there's lots of smart people out there that can help these designers and these engineers come up with better solutions. So this is where I find that the stakeholders all involved with a level playing field and on the same table could probably get things done. That's my take on it.
I think in closing, what I just want to add is that we live in a world where technology is changing rapidly. We now having a discussion on lithium-ion batteries and the risks. In the same space and time, the hydrogen vehicle technology is also becoming more mature, and that even in itself has unique risks. And ultimately, with hydrogen, which is a colorless, odorless gas that burns at extreme temperatures, and that creates unique problems. And battery technology is continually changing, and propulsion technology is continually changing. And the amount of plastics and the type of plastics we use in these vehicles are continually changing. The way we risk assess and fight fires and detect fires hasn't changed much in the last 50 years. But the risks that we're trying to fight has changed significantly. And the message really is the technology exists today where we have the ability to condition monitor a lot earlier. And with a fully approved system that carries FM and UL and VDS approvals for fire detection, but has the ability to give actionable real-time temperature information. And we can only really control what we can understand. And this information would be so valuable to, one, the initial evacuation of people within that environment, as well as the fire team, how to deal with this risk early on and a lot earlier than what traditional technologies would allow. And I believe that fiber optic sensing and our Luna detect systems is the solution, or at least forms part of the bigger solution in how to deal with this problem in the future, today and into the future.
People like myself that are bringing these new ideas and solutions to the market, and we're trying to get it out through any way we can, which is one of the ways we're doing it through this podcast. And I'm very proud of that. This might be a doorway to at least letting these things be heard. And if they fall on deaf ears, they fall on deaf ears. It won't be on my conscience that I didn't try to put this out there.
When it comes to building safety, David Moss is right there on the ground floor, so to speak. He's seen firsthand the craftsmanship that goes into construction. He's seen the good, and he's seen the ugly. Shoddy work and cutting corners almost always leads to disaster. It's even more important to pay attention when it comes to something as critical as a house or a car. Advancement in technology is exciting. There's no doubt about that. Whether people adopt tech like solar or electric vehicles because of their environmental impact, or because they just want to get a hold of the new hotness, the world is changing and everything is trending greener and more efficient. EVs are the reality now, not just the near future. There's going to be an adjustment period when it comes to safety regulations, and it's up to policymakers to be proactive and try and prevent disasters from happening, because the potential and destructive power is all there, and we're not ready. And David Moss is determined to keep on pushing the issue. If it's not clear already, he's a rules guy, but he goes beyond the book too, because the book is not up to date. In this industry, you gotta have a good survival instinct, and he's had 40 years of working with new technology. For David Moss, it's about taking risks when it counts, but not doing yourself in. It's about method and the right way of getting it done, especially if it means keeping people safe.
Another Everything Podcast production.